Okay, right now, good evening, guys. Have you all read about the chapter 5.3 and chapter 5.4 as instructed by Miss Noor Amalina?
Already.
Yes. Okay,
Yes, I already read.
okay. So we will start with the part 5.3a, which is the critical temperature and pressure. Any questions on this part so far?
I have question.
Yeah, please state your questions.
My question is, in what situation should we apply virial equation of state?
Oh, you mean the part 5.3b, yeah?
Yeah. Yes.
Oh, okay. Okay, for the part 5.3b, virial equations of state, yeah, virial equation of state should be applied for the description about the isotone of a real gas only. Since this equation expresses the deviation from ideality in terms of a power series in the inverse of specific volume, as shown in the equation 5.31. Yeah, so it does only apply to describe about the real gas at constant temperature. Yeah, and this equation is usually to solve used to solve the unknown pressure when the volume of the real gas is given. Yeah, that's my answer to your question. So any other answers?
Yes, I agree with Yong-Sun.
So if we have a constant pressure, we cannot use this equation lah. Just when we have a constant temperature.
Not necessarily, but actually the this equation is used to make a description about the real gas at constant temperature, not the constant pressure. Based on my understanding, yeah. So we especially it is used to solve the pressure one. If the what the volume of the real gas is given. Yeah.
Oh, okay.
Okay.
Thank you, Yong.
Okay, welcome. Okay, so any other questions about this part 5.3b virial equations of state?
No.
What is the pizza eccentric factor and when should we use it?
That one, Danny, eccentric factor was first proposed by Pizza as a measure the amount by which the thermodynamic properties of a particular substance differ from those predicted by the principle of corresponding states. So this principle strictly applies only to a fluid, liquid, or gas comprised with spherical molecules. In other words, it is a parameter that reflects the geometry and polarity of a molecule. So that's my answer.
Okay, thank you.
So any other questions? If no, we can go to we can proceed with another part. Agree?
Yes, we can proceed.
Yes.
Okay.
Proceed.
Let's proceed. And okay, for the part 5.3c, cubic equations of state. Any questions? So far, any question?
No question from me.
No question from me.
Okay, then we proceed with chapter 5.4, which is the compressibility factor of equation of state. So okay. So any questions for the part 5.4a about compressibility factor tables? I think no, right? Just look through the tables.
Yeah,
Okay.
it's so.
So let's proceed. Okay. So okay, the law for 5.4b, the law of corresponding states and compressibility charts. No question so far?
I have some question.
Mm.
So in this subtopic, there are K rule mentioned. So what's the meaning of K rules? And when we apply it?
Anyone wants to answer that?
Diva, can you repeat your question? I'm not quite clear.
Oh, I'm sorry, the K rule is 5.4C.
Oh, 5.4c. Okay.
Okay.
Okay. Never mind. Let's proceed. For the non-ideal gas mixtures. Okay.
Yeah, that's bold one.
Oh, K rule.
K rule.
Okay.
Yeah.
So repeat your question. Yeah.
I wanna ask what is K rules and when we apply it, since it's involving non-ideal gas, so too many formulas, so I confuse when we want to use K rule, when we want to use cubic, or like that.
Oh, okay. I see. Mm.
I also don't know.
Okay, I will answer that your question. Okay, for the case rule, it is actually used to estimate the pseudo-critical properties of mixtures as simple averages of pure component critical constants as stated in the book. Uh, uh, just for your information, that we will need to use the pseudo-critical temperature and pressure. When we are given a non-reacting gas mixture that consists of uh, the non-ideal gas or real gas, yeah, okay. If the gas deviation factor is not measured, then it may be estimated from the correlations, and the correlations actually depend on the pseudo reduced temperature as mentioned here, and and the and the pre and the pseudo reduced pressure, yeah, which in turn depends on the uh, pseudo critical temperature and pseudo critical pressure, which means that we need to find first the pseudo critical temperature and pseudo critical pressure by using the formula as stated here. So pseudo critical temperature, its formula is uh, the summation of the mole fraction of each component times the critical temperature of each component in the mixture. Yeah, same way goes to the pseudo critical temperature, and then we find the pseudo-reduced temperature and pressure nets. So, is that clear so far?
Clear. So the DC and PC we can find in table B.1, right?
Yes, refer to the table B.1.
Thank you.
Yeah, okay, welcome. So, any question?
So this pseudo critical is like the average of the temperature, something like that.
Yeah, it may, yeah, uh, like the like we find the average line. I think so.
Because they have many mixtures like yeah
Many component.
yeah
It
many
has
components.
many component.
Mm,
So we need to combine them.
yeah.
Okay, I see.
Okay, I have a question here. Okay, what does it mean by the pseudo-critical temperature and pseudo-critical pressure here?
Pseudocritical temperature is the highest temperature at which species can coexist in two phase, which is the fluid phase or the gas phase. So DC is critical, right? So by pseudo critical temperature is the average of all the critical temperature. This can apply in many, like if you want to calculate one mixture which have many component in it, like we have hydrogen, oxygen. So if we calculate one by one, it may take a long time. So we try to combine it and get the average. So same goes to pressure lah. Is those critical pressure. Normal.
Okay, I see.
Is it clear?
Yeah, I'm clear.
Uh,
So, any question so far about this part? Okay, if no questions, then I will stop recording again.